Ancient engineers may have terraformed entire continents to control the climate. This video uncovers the lost civilization that mastered environmental engineering on a grand scale, leaving behind a fabricated record of the past in dry valleys and dams. By the end, you will understand how they manipulated Earth's very geology and what that means for our own future. We will explore why a society would build massive structures just to change the story the land tells, and what happened when their engineered world began to crumble. How much of our ancient history is a carefully crafted illusion? These vast, silent expanses of dry valleys hold a secret in their very emptiness. We see a barren landscape, a place seemingly abandoned by water and life. But what if this desolation is an illusion? What if these valleys are not a natural end but a deliberate design? Geoarchaeologists studying these regions have noted features that simply do not add up. The patterns of sediment are inconsistent, layered in ways that do not match known models of wind or water erosion. The channels cut into the earth seem to follow a logic that defies the random path of a river, appearing more like an engineered network for directing water. This suggests a radical idea that these landscapes were not just shaped by nature, but were actively sculpted by human hands. Imagine the ambition of a society that looked at a fertile river basin and decided to reroute its very lifeblood to carve new paths for water on a continental scale. Their goal was not just irrigation, but something far grander: the control of regional climate itself. By managing where water flowed and where it was stored, they could influence rainfall, temperature, and ultimately, the habitability of entire regions. This transforms our understanding of these empty places from forgotten wastelands into the most profound artifacts of a lost civilization. They are the silent, crumbling testament to an ancient will to command the environment. And the tools they used to achieve this staggering feat lead us to the most enduring and visible of their creations, the colossal dams that held their new world together. These dry valleys are geological forgeries. In places like the Atacama, the ground tells a story that nature alone could not have written. The soil is layered with a precision that mimics the pages of a book, with mineral deposits arranged in sequences that speak of regular, managed water flow, not the chaotic gift of rare desert storms. Deep beneath the surface, scans reveal the ghost of a plumbing system, a network of subterranean channels that once guided water with purpose. Climatologists point to the sheer statistical unlikelihood of such perfect formations, arguing that the evidence points toward a controlled environment, not a wild one. The proof is etched into the very chemistry of the Earth. When scientists analyze the isotopic composition of the sediments, they find a signature of artificial enrichment. Unusual concentrations of specific elements appear, like a fingerprint left by ancient hands. These anomalies hint at sophisticated techniques, perhaps a form of large-scale fertilization or a deliberate diversion of water to nourish specific areas. This forces a profound question. If these barren valleys are not a natural graveyard but a carefully constructed stage, what performance were they meant to host? What grand narrative about the climate was being carved into the continent? To understand the purpose behind this fabricated record, we must look to the massive structures that made it all possible. The sophistication of these dams is what truly defies belief. We are not looking at simple piles of rock meant to hold back a seasonal river. These are intricate hydrological machines, built with a foresight that seems to span centuries. Their spillways are carved to handle immense, calculated volumes of water, not just random floods. Their sluice gates show evidence of complex mechanisms for precise control, allowing engineers to release water in measured amounts, like turning a tap for an entire region. In the high Andes and in the remnants of Mesopotamia, these structures are found physically connected to the very dry valley networks we just explored. They were not separate projects, but two parts of a single, breathtaking ambition to command the entire water cycle of a landscape. Hydraulic engineers who study these ruins are often stunned by the knowledge on display. The builders possessed a deep, practical understanding of water pressure and sediment flow. Their designs include features that prevent silting, ensuring the reservoirs would remain functional for generations. This was not just about storing water, it was about creating and sustaining entirely new geological features. By controlling the release of water and sediment, they could deliberately form vast, fertile lake beds and alluvial plains where none existed before. They were, in essence, printing a new kind of climate history directly onto the land. This leads to the most staggering implication. These dam networks were used to fabricate a water cycle. They could simulate the geological evidence of a consistently wet climate, even during prolonged periods of drought. Imagine a series of reservoirs in ancient Sri Lanka, known as the Cascade System. These were not isolated tanks, but a linked chain of artificial lakes that created their own localized weather patterns. The evaporation from one reservoir would contribute to rainfall for the next, generating a self-sustaining green corridor. This proves the concept on a smaller scale, a proof of principle for what a larger civilization might have attempted across a continent. They were not just adapting to their environment, they were writing a new one into the very rock and soil. So what does this immense, coordinated effort tell us about the people who built it? Their priority was not merely survival, but the creation of a permanent, stable, and controllable world. They sought to eliminate the unpredictability of nature, to replace climate with a system of their own design. This reveals a society so advanced and so confident that its primary goal was to become the author of its own destiny, leaving behind a fabricated geological record as their ultimate signature. But such grand ambitions are never without their consequences. To understand the full story, we must ask what happens when an engineered world begins to fail, and what desperate measures were taken to preserve its illusion. The sheer scale of this engineering points to a motive far beyond simple survival. This was a civilization confronting a profound crisis, a shifting climate that threatened its very existence. Perhaps a great drought was turning their world to dust, or an encroaching ice age was stealing their farmland. In such desperation, control over the environment becomes more than a practical need. It becomes the foundation of power. To maintain order, to attract settlers to new territories, or to justify their rule, these ancient engineers may have needed to create proof of a stable, hospitable world. They did not just build infrastructure, they built a narrative. We see this pattern throughout history, where empires use the perception of environmental security to consolidate their control. Anthropologists suggest that by fabricating a favorable climate record, a ruling class could direct migration, manage resources, and present themselves as the guarantors of prosperity. They were not merely manipulating water, they were manipulating belief. The evidence for this is etched into the very biology of these sites. Pollen records and fossilized plant remains found near the dry valleys and dams often tell a contradictory story. In the midst of a naturally arid biome, scientists find the preserved traces of water-intensive crops, species that could never have survived there without massive, sustained human intervention. This is the smoking gun, a landscape deliberately dressed with the wrong kind of life to sell an illusion of abundance. It forces a powerful question. If you had the ability to shape the perceived reality of your world, to make a desert appear as a garden through engineered evidence, what absolute power would you hold? This grand deception required more than brute force. It demanded a deep, almost prophetic understanding of how geological processes work over centuries. They had to know how rivers carve land, how sediments layer, and how future scientists would read the story of the Earth just to write a convincing forgery. But such a delicate illusion is always vulnerable. A single miscalculation, one prolonged drought beyond their capacity, and the entire fabricated world would begin to crack, revealing the terrifying truth hidden just beneath the surface. The most damning evidence is written in stone itself. Beneath the surface of these dry valleys, the story told by the Earth is a lie, meticulously constructed layer by layer. Geologists examining core samples have found strata that are unnaturally uniform, a perfect stacking of sediments that nature, in its chaotic beauty, rarely produces. This artificial compaction was a deliberate act, a way to accelerate the natural process of sedimentation and create a false timeline of climatic events. Think of it as building a geological record on fast forward, fabricating centuries of stable, wet conditions in just a few generations. The goal was to leave behind a permanent testament to a climate that never truly existed. Even the bedrock tells a strange tale. In certain valleys, the solid rock bears marks that look less like the slow grind of wind and water and more like the deliberate strikes of tools. These are not random scratches, but systematic channels and grooves, suggesting large-scale quarrying or the intentional shaping of watercourses. It is as if the very land was being sculpted from the ground up. Stratigraphers, the scientists who read the history of the Earth in its layers, are often baffled by these sites. They point out that natural deposition creates messy, irregular bands of material, a jumbled story of floods and droughts. The pristine, orderly layers found here point to only one thing: a managed process of filling or draining, a conscious hand guiding the soil into place. So how was this geological forgery achieved? The method reveals a terrifying precision. This civilization used their network of dams not just to store water, but as a printing press for the landscape. They would sequentially release massive, controlled volumes of water, each pulse carrying a specific type of sediment. One release would deposit a layer of fine clay to mimic the slow, quiet bed of an ancient lake. The next would spread a band of coarse gravel, designed to look like the remains of a powerful river. In this way, they could construct an entire geological column from the ground up, a fabricated history book with chapters written in mud and stone. We see a potential example in the terraces of the Negev Desert. These vast, stair-like structures are often explained as simple water harvesting projects. But what if their true purpose was far more profound? What if they were built not just to catch rare rainfall, but to leave a permanent, undeniable imprint of fertility in the soil? By controlling the flow of water and sediment across these terraces, the engineers could create layers of rich, organic peat and clay that would future scientists into believing this was once a lush, well-watered plain. The most haunting question is how these fabrications have endured for millennia. Their resilience is not an accident, it is the ultimate proof of the builders' foresight. They understood geology better than we can sometimes comprehend. They knew how to work with natural forces, not against them, using the very processes of erosion and deposition to cement their lie into the planet's permanent record. They built a false past so convincing that it has weathered the ages, waiting for us to finally read between the lines and see the hand that wrote them. This civilization's identity is the ultimate historical puzzle. We are searching for a society with the power to reshape continents, yet one that seemingly vanished without leaving a clear name or capital behind. The candidates are as enigmatic as the evidence itself. Perhaps it was a culture like the Norte Chico of Peru, whose immense ceremonial centers predate the pyramids and whose existence was entirely dependent on sophisticated water management in an arid land. Or maybe it was a predecessor to the Indus Valley civilization, known for its meticulously planned, waterproofed cities and sudden, mysterious decline. Some even look to the legend of Atlantis not as a sunken city, but as a metaphor for a real, advanced society that mastered hydrology before collapsing. These cultures all share a common thread, an unexplained peak of engineering followed by a rapid fade from history. Their myths and texts are filled with stories of great deluges and gods who controlled the rains, which could be distorted memories of their own monumental climate engineering projects. To orchestrate such vast terraforming, this civilization would have required a central authority of unimaginable power, a single, ruling entity capable of commanding labor forces for generations and directing resources across thousands of miles. They would have possessed advanced mathematics for precise land surveying over immense distances, and a motive powerful enough to justify the centuries of labor, likely rooted in existential survival or aggressive territorial expansion. When we compare their work to known ancient structures, the technical links become startling. The laser-like precision of stone cutting seen in Egyptian obelisks finds a haunting parallel in the clean, tool-marked channels of certain dry valleys. The massive, gravity-defying dams of ancient Mesopotamia share a fundamental design philosophy with the hydrological machines we find in the Andes, a focus on controlling immense pressure and managing sediment. This suggests a shared and perhaps even older source of knowledge. So why has such a powerful civilization left so few obvious traces like statues or written records? Perhaps because their greatest monument was not a city of stone, but the very landscape we walk upon. Their legacy is written in the manipulated riverbeds and the falsely layered valleys, a record we mistook for nature's work. This realization forces a profound shift in how we view our own past, and more urgently, it raises a critical question for our future. If an ancient society could so thoroughly overwrite the planet's geological history, what does that mean for our own attempts to understand and combat modern climate change? The water itself tells the final, undeniable part of this story. Across these ancient landscapes, rivers seem to disobey the very laws of geography, taking sharp, unnatural turns that defy the logic of gravity and terrain. We find the fossilized shorelines of vast lakes perched at impossible elevations, their former beaches sitting high above any basin that could have naturally contained them. These are not random quirks of nature, they are the lingering echoes of a redirected hydrology. In the Jordan Valley, hydrologists have mapped groundwater patterns that pulse in a rhythm completely out of sync with the region's climate history. The water table rises and falls in a way that aligns perfectly with the ruins of ancient irrigation channels, not with millennia of rainfall or drought. This reveals a system of artificial recharge, a deliberate effort to pump life back into the very aquifers, sustaining them from below long after the surface had dried. The energy required for such an undertaking is staggering to contemplate. It points to a society with not just advanced planning, but with a seemingly endless supply of coordinated labor, all directed toward a single, monumental goal. They were not just managing water, they were replumbing entire continents. To understand the method, look to the ingenious technologies they deployed. Deep underground, networks of kanats, those gently sloping tunnels that tap into mountain aquifers, would have fed water into these grand systems without a single drop lost to evaporation. Elaborate stepped wells, some descending hundreds of feet into the earth, acted not just as water sources, but as passive cooling towers and community hubs, all while maintaining the precise water levels needed for the larger scheme. These features created self-sustaining hydrological cycles, where the very act of using water helped to perpetuate its flow and availability. The ancient city of Petra stands as a brilliant case study. Carved into desert cliffs, its inhabitants mastered water capture with a network of dams, cisterns, and channels. This engineering did more than just quench thirst. It created a persistent microclimate of cool, moist air around the city, allowing gardens and agriculture to flourish in the heart of the desert. Now magnify that concept to a continental scale. Imagine using such techniques not just to sustain a city, but to fabricate the evidence of an entire regional climate. By strategically maintaining artificial wetlands in otherwise arid zones, these engineers could support specific plants and animals, leaving behind a biological record that would later scream fertile paradise to any researcher who found it. They could make a desert appear to have been a land of permanent lakes and flowing rivers. This scale of manipulation reveals a civilization with a relationship to nature that is both awe-inspiring and sobering. They did not see the environment as something to worship or simply live within. They saw it as a vast blank canvas, and they held the brush. Their ambition was to paint a new world onto that canvas, one where the climate itself was a story they could write and rewrite. But a canvas can be torn, and a story, no matter how well written, can eventually be proven false. The tools they wielded were deceptively simple. Bronze chisels, stone hammers, and wooden levers were their primary instruments. Yet, with these basic elements, they achieved geographical changes we would struggle with today. Their true power did not lie in the tools themselves, but in the profound knowledge they applied. They possessed an almost modern understanding of astronomy, using celestial patterns to predict seasonal water flows. They read the geology of a landscape like a map, identifying the weakest points in a rock face and the most efficient paths for water. Experimental archaeologists have proven this is possible. By organizing large groups of people using only replica tools, they have moved massive stones and carved new channels, demonstrating that coordinated human effort, guided by precise knowledge, can literally reshape the earth. This knowledge was applied with breathtaking scale. Terrace farming was not just a method for growing crops on hillsides, it was a continent-scale strategy for controlling erosion. By cutting vast staircases into mountains, they slowed the flow of water, trapped precious soil, and created entirely new, arable land from sheer slopes. They even understood the principles of albedo, which is how much light a surface reflects. There is evidence they used fire to clear dark vegetation and may have spread organic dyes or crushed minerals to darken the ground. A darker surface absorbs more heat, subtly raising local temperatures and extending the growing season in a carefully managed microclimate. Another technique, known as lithic mulching, involved spreading a layer of stones across fields. This acted like a blanket, retaining soil moisture and trapping heat, again artificially manipulating the environment to favor agriculture. The sophistication of their water management is staggering. Ancient engineers, whose names are lost to time, spoke of the critical importance of slope calculation and water flow dynamics. Their surviving structures show they knew how to measure a gradient to the fraction of a degree, ensuring water moved with just the right speed to prevent erosion yet carry away silt. We see this principle perfected in the chinampas of ancient Mesoamerica. These were not simple gardens, but artificial islands built in lake beds. By weaving together reeds, mud, and vegetation, they created incredibly fertile plots of land that effectively modified the lake environment itself, turning stagnant water into a productive, living system. This was environmental engineering at its most elegant. This leads to a final, haunting question. How did they transmit such complex, system-wide knowledge across generations without a clear, universal written language? The techniques for building a dam or calculating a slope are not simple recipes. They are intricate sciences. The survival of their entire fabricated world depended on this chain of knowledge remaining unbroken. This forces us to look beyond the physical tools and consider the most powerful instrument they must have possessed, a system of science and record keeping so effective it allowed them to plan for centuries. The most damning proof lies in the frozen archives and the rings of ancient trees. Ice cores drilled from glaciers and tree rings from long-lived forests tell a consistent, global story of past climates, a slow and rhythmic dance of temperature and rainfall over millennia. Yet when we look at sediment cores extracted from these engineered dry valleys and their associated dams, the story suddenly fractures, the timelines clash violently. In these manipulated landscapes, the geological record shows abrupt, dramatic shifts that simply do not appear anywhere else. Paleoclimatologists point to these stark discrepancies as a glaring red flag. Natural climate change is a slow, creeping process affecting vast regions in unison. What we see in these specific sites is not natural. It is the signature of a switch being flipped, a localized environment being forced into a new state by human hands. Carbon dating adds another layer of mystery. Organic materials recovered from deep within the dry valleys often return ages that are wildly out of sync with the geological layers that encase them. A piece of wood or a layer of peat might be dated to 1,000 years ago, while the sediment above and below it suggests an age of 5,000 years. This is not a dating error, it is evidence of introduced material. Imagine an engineer carefully placing a piece of old wood into a layer of freshly deposited mud, a deliberate act to make a new landscape appear ancient. This is how you forge time itself. The biological evidence is equally compelling. In the heart of a desert stratum, scientists sometimes find the preserved pollen of moisture-loving plants or the fossils of aquatic snails. In a natural system, this would be impossible, but for a civilization fabricating a climate record, it was a calculated move. They could import rich soils from distant, wet regions, or use their managed irrigation to create a localized wetland that would leave behind precisely these kinds of biological markers. They were not just building a landscape, they were stocking it with the right props to sell the illusion. A powerful case study emerges in the Sahara Desert. While it is true that the Sahara experienced natural green periods in the deep past, some evidence suggests that more recent phases of lush vegetation were not purely natural. They may have been sustained or even initiated by sophisticated pastoral societies who managed the land with fire and water, creating a greener Sahara for a time through deliberate intervention. This shows the principle on a smaller scale, a proof of concept for how a more advanced civilization could have done the same thing, but with the explicit goal of leaving a false record. So why would any society go to such incredible lengths to falsify the very data of their own existence? The motivation cuts to the heart of power and survival. Control the narrative of the past, and you control the resources of the present. By creating geological proof of a perpetually wet and fertile climate, a ruling class could justify their claim to the land, attract a large population to work it, and present themselves as the divine or technological guarantors of this abundance. In a world facing a real climate crisis, this fabricated stability would be the ultimate source of authority. It was a desperate, audacious gamble to write their own reality into the bedrock of the planet, ensuring their legacy would be read not as a fleeting empire, but as a golden age ordained by the earth itself. But such a grand deception requires one final, crucial element, a system of knowledge so powerful and precise it could coordinate this lie across a continent. Living within such a carefully curated world would fundamentally reshape every aspect of society. For the average person, the landscape would simply be fertile, the rains reliable. They would have no reason to question the stability around them, believing the myths and religious stories that explained their good fortune as a divine gift. This engineered abundance allowed populations to swell in areas that were naturally marginal, supporting the dense cities and complex social structures we associate with great civilizations. But this stability came at a profound social cost. Sociologists point out that control over the very environment creates the ultimate form of power. A small, elite class of engineers and priests would have held the keys to the system, the only ones who understood the intricate network of dams and channels that kept the desert at bay. This knowledge allowed them to consolidate their authority, positioning themselves as the indispensable intermediaries between the people and the forces of nature. Historians of ancient economies note that such guaranteed harvests would have been an economic engine. With a reliable food surplus, labor could be diverted from mere subsistence to grander projects. This is the pattern we see in empires like the Romans, where stable agriculture funded vast trade networks, monumental architecture, and ambitious military campaigns. The entire society was built on a foundation of controlled climate. This false narrative would have been woven deeply into the cultural fabric. Religious rites and seasonal festivals would not celebrate the whims of nature, but instead give thanks to the rulers who provided these ideal, seemingly heaven-sent conditions. The elite class would be seen as divinely favored, their right to rule reinforced by the perpetual spring they appeared to command. But such a system carries the seeds of its own destruction. Its greatest strength, its stability, is also its greatest vulnerability. The entire society becomes dependent on the continuous, flawless maintenance of the environmental machinery. If that maintenance failed due to political unrest, a loss of technical knowledge, or a drought that exceeded the system's capacity, the collapse would be swift and catastrophic. The very fertility that supported the population would vanish not over centuries but within a few generations. We see this pattern in the classic Maya. Their intensive agriculture, involving massive canal systems and wetland fields, created a flourishing yet profoundly fragile, artificial environment in the heart of the jungle. When a prolonged drought struck, their engineered systems could not compensate. The land that had fed millions reverted to its natural state, unable to support the great cities, leading to a rapid and dramatic societal decline. What happens when the illusion can no longer be sustained? The collapse leaves behind more than just ruins. It leaves a landscape of clues, a silent testament to a gamble that failed. This forces us to reconsider the evidence we find at other ancient sites, not as signs of a changing climate, but as the ghost of an engineered reality breaking apart. The true mystery then becomes not how they built this world, but how we can learn from its fragile design before we repeat the same mistakes on a planetary scale. Buried alongside these grand hydrological works are the tools that made them possible. In the dust of forgotten storerooms, archaeologists have unearthed artifacts that tell a new story. These are not typical farming implements or simple water pots. We find specialized plows with blades designed not to till soil, but to carve precise irrigation channels. We recover intricate sluice gate mechanisms made of bronze, far more complex than needed for a simple village well. Most telling are the advanced surveying tools, devices for measuring angles and levels with an accuracy that rivals modern instruments. These objects are often found in places that make little sense, like a massive water-lifting device called a noria discovered in the center of a valley that has been bone dry for millennia. It is a machine without a purpose unless its purpose has since vanished. Inscriptions on temple walls depict vast water distribution networks, with canals and reservoirs drawn on a scale that seems almost mythical. Why would a society illustrate such immense systems if they were only watering crops? The diagrams show a control over water that goes far beyond agriculture, pointing toward a deliberate, managed environment. Expert analysis confirms that the locations where these strange artifacts are found form a perfect overlay on the map, connecting the anomalous dry valleys and the colossal dam sites into one coherent, continent-spanning pattern. This was not a series of isolated projects. It was a single, unified program of environmental control. The infrastructure itself reveals the methods of this grand deception. Consider the carrés, those underground channels that tap into mountain aquifers. A network of carrés is invisible from the surface, a secret way to move vast quantities of water across a desert without a single drop lost to evaporation. This technology could have been used to create phantom oases, to sustain a patch of lush greenery in the middle of a barren plain, leaving behind biological evidence of a wet climate that was entirely artificial. The ambition is further revealed in the architecture. Temples and administrative buildings at these sites are often aligned with celestial events, their doorways and windows framing the sun on the solstices or specific stars. This was likely more than just ceremony. It could have been a precise calendar, a way to time the release of water from dams to mimic the natural, seasonal flooding of a river that no longer existed. They were not just managing water, they were performing the illusion of a natural water cycle. Ancient Persia offers a stunning case study of this capability. Their Qanat systems were marvels of engineering, chains of vertical shafts connected by gently sloping tunnels that brought water for dozens of miles to sustain cities in the most arid landscapes. This was large-scale hydrology in action, proving that an ancient society could indeed replumb an entire region. So how do these scattered plows and intricate gears change our perception of the past? They reveal a technological prowess we are only beginning to appreciate. This was a civilization that did not merely build monuments to their gods or kings. They saw engineering as a path to immortality itself, crafting a legacy not in stone, but in the very climate and geology of the planet. Their tools were the brushes with which they painted a new world onto the canvas of the earth. The myths our ancestors told were far more than just stories. They were survival manuals disguised as legends, encrypted blueprints for controlling the very world. When a Sumerian deity like Enki commands the sweet waters beneath the earth, we are likely hearing the echo of the first hydraulic engineers, the master planners who designed Mesopotamia's earliest irrigation canals. These tales of gods bringing order to chaotic rivers are not pure fantasy. They are a culture's memory of its greatest technological triumph, the taming of a landscape. This pattern repeats across the globe, the recurring motif of a lost golden age, a time of perfect weather and endless abundance, perfectly mirrors the periods when these vast environmental systems were functioning at their peak. The land was fertile, the climate stable, and it was all by human design. The stories preserved this memory of engineered perfection long after the machinery itself had crumbled into dust. Folklorists have long noted that oral traditions often contain incredibly precise practical knowledge. A song about a hero's journey might secretly describe the safe path through a treacherous mountain pass, or a folk tale about a water spirit could encode the exact location of a critical aquifer. These narratives were the hard drives of the ancient world, storing vital data about which dams needed annual maintenance and which valleys were deliberately carved by human hands. We see this clearly in the Aboriginal Dreamtime stories of Australia. These ancient narratives describe in exact detail river courses and lake systems that have been completely dry for thousands of years. This is not a faulty collective memory. It is a profound and accurate record of a landscape that was once actively maintained, a wetter world sustained by human intervention. Even place names act as linguistic fossils, revealing a past that geology has tried to hide. A town called Riverbend in the heart of a desert, or a valley named Greenfields that is now a barren wasteland. These names are not mistakes. They are stubborn remnants of the truth, labels from a time when the environment was a carefully curated project. So why go to such lengths to hide this knowledge in plain sight? Because stories outlast empires, stone inscriptions weather away, and written records can be burned, but a compelling myth, passed from parent to child over a campfire, can survive for millennia. It is the most resilient form of information storage ever invented. By encoding the secrets of their climate control within their most sacred stories, this civilization ensured that the knowledge and the warning would never truly be lost. It simply waited patiently for a future generation to learn how to listen. From the silent earth, we now look to the silent sky for answers. The most compelling evidence for this continent-spanning project comes not from the ground, but from orbit, where satellites capture the ghostly fingerprints of this ancient civilization. Modern remote sensing technology peels back the layers of time, revealing patterns and structures that are completely invisible from the surface. In the deserts of Saudi Arabia, satellite imagery has uncovered vast, enigmatic lines and geometric shapes known as the gates. These are not natural formations, but the remnants of massive, low stone walls that once channeled water and trapped fertile soil. A clear signature of large-scale environmental management in a place we once believed was always barren. This is not an isolated case. In Central America, LiDAR technology, which uses laser pulses to map the ground beneath dense jungle canopies, has exposed staggering networks of canals, agricultural terraces, and roadways. These discoveries prove that what we thought was pristine wilderness was actually a carefully engineered landscape, a managed environment on a scale that dwarfs our modern understanding of these ancient cultures. Remote sensing experts emphasize that this technology finally allows us to see the complete picture. Isolated ruins and strange dry valleys are not separate mysteries. They are individual nodes in a vast, interconnected system. The civilization did not just build cities, it engineered entire watersheds. Multispectral imaging is the key to this revelation. This technique measures light wavelengths beyond what our eyes can see, detecting subtle differences in soil moisture and vegetation health. It can pinpoint the precise location of buried stone foundations or the compacted earth of an ancient canal, even if it lies several feet below the surface. For instance, infrared photography over a known dry valley might reveal a dark, damp line snaking beneath the dust, the spectral ghost of a subterranean aqueduct that once fed water directly into that barren basin. This is the definitive proof that these valleys were not naturally dry, but were artificially created and sustained by a hidden hydraulic system. A powerful case study is the ancient Maya city of Caracol in Belize. For decades, archaeologists believed it was a modest ceremonial center. Then, LiDAR surveys painted a radically different picture. The scans revealed a sprawling, densely populated metropolis with an intricate web of agricultural terraces, reservoirs, and causeways that transformed the entire region. They had turned a challenging jungle environment into a highly productive, engineered landscape. This mastery of spatial planning is what truly challenges our assumptions. The civilization's engineers did not just react to their geography, they commanded it. They viewed continents as a blank grid, plotting the locations of dams, canals, and farmlands with a precision that suggests advanced surveying and a centralized, long-term vision. They were not simply building within their world, they were designing a new one from a bird's-eye view, a perspective we are only now, millennia later, able to fully appreciate. This grand ambition forces us to confront a difficult ethical question. Where does the line fall between brilliant survival and dangerous arrogance when a society reshapes the very world it depends on? These ancient engineers were not just building structures, they were making a fundamental choice about humanity's relationship with nature, a choice that carries profound moral weight. They prioritized immediate human need and stability, but in doing so, they may have set in motion ecological chains of collapse that doomed future generations. Ethicists point to the unavoidable trade-offs of such large-scale manipulation. A massive irrigation network could feed a city for a century, but the same system might slowly poison the land with salt, a process called salinization, rendering the soil barren for 1,000 years. The creation of a vast, artificial lake could support new fisheries, but it would also drown entire ecosystems and displace the species, and possibly the human communities that once thrived there. This is the dark shadow of their ingenuity. The archaeological record is filled with civilizations that ultimately crumbled under the weight of their own engineering. The once fertile fields of Mesopotamia, cradle of some of the earliest hydraulic societies, were eventually abandoned, their soils exhausted and salted by the very canals that had made them rich. This pattern suggests that the success of these projects often contained the seeds of their own destruction. So was this climate evidence engineering an act of desperate survival or monumental hubris? The answer is likely both. A society facing a true existential crisis like a worsening drought would be desperate to secure its future. Yet the scale and permanence of their solution, the act of carving a false climate into the planet's record, speaks to a staggering confidence in their own right to command the Earth. We can see a potential example in the history of the ancestral Pueblones, sometimes called the Anasazi, in the American Southwest. Their sophisticated water catchment systems and cliff dwellings represent a brilliant adaptation to a dry land. Yet, some researchers debate whether their intensive farming and forestry practices, combined with a prolonged drought, contributed to the very desertification that eventually forced them to abandon their magnificent homes. Their story is a powerful and haunting case study in the unintended consequences of environmental control. This historical perspective raises a critical question for us today. As we now debate our own large-scale interventions, like spraying particles into the atmosphere to reflect sunlight or fertilizing the oceans to absorb carbon, we are facing the same ethical dilemmas. How do we balance our undeniable need for stable climates with our responsibility to the health of the planet and to generations not yet born? The ruins of these ancient civilizations stand as a silent warning. They achieved wonders, but their legacy is a landscape of both grandeur and collapse. Their story is not a simple lesson, but a complex mirror, forcing us to ask what price we are willing to pay for control and what kind of world we will leave behind in the geological record we are now writing. The soil itself holds a confession. Deep within the dry valley beds, core samples reveal a chemical story that nature never wrote. Geochemists drilling into these barren grounds find startling spikes in phosphates and nitrates, the classic fingerprints of ancient fertilizers. These nutrients are not spread thinly as they would be from natural decay, but are concentrated in specific, artificial layers, pointing to a massive, sustained agricultural effort where none should exist. The water that once flowed here left its own damning evidence. Isotopic ratios of oxygen and hydrogen trapped in mineral deposits tell a tale of manipulated sources. The water did not come from a single natural watershed, but from a blended cocktail, a mix of distant mountain snowmelt and recycled reservoir water, precisely the signature you would expect from a managed hydrological network. This is not the chemistry of a wild river, but of a faucet turned on and off by human hands. Even more revealing are the heavy metals. Sediment layers contemporary with the great dams show elevated levels of lead and copper, pollutants from industrial-scale metalworking. This suggests a civilization advanced enough to produce the vast quantities of tools and fittings needed for continent-spanning hydrology, their workshops leaving a permanent stain on the geological record. These chemical clues act as a precise clock, dating periods of intense activity that align perfectly with the proposed era of climate engineering. How did they achieve such specific environmental conditions? The evidence suggests they were not just moving water, but actively doctoring the soil itself. By adding substances like lime, they could alter the pH of vast tracts of land, making it suitable for crops that would otherwise never grow there. This created a self-reinforcing illusion. The presence of these specific plants and the fossils they left behind would later be interpreted by scientists as proof of a naturally wet and fertile climate. Consider the discovery of certain freshwater algae fossils in the heart of a desert stratum. In a natural system, this would be a baffling anomaly, but in an engineered one, it makes perfect sense. These algae would have thrived in the temporary, dam-created reservoirs that dotted the landscape, their microscopic remains becoming permanent props in the grand stage play of a false climate. A powerful case study emerges from the Nile Delta. For thousands of years, the practices of ancient Egyptian farmers, their use of organic fertilizers and irrigation, have permanently altered the sediment chemistry of the entire region. This demonstrates the profound and lasting impact a society can have on the very elements of the earth. On a much larger scale, the civilization we are investigating was doing the same thing, but with a conscious goal to mislead. They were not just feeding a population, they were planting evidence. These microscopic chemical traces build a macroscopic story of intentional design. They are the forensic proof that this was not adaptation, but authorship. Every manipulated isotope and every anomalous metal concentration is a single pixel in a vast picture, revealing a society that sought to control not just the water and the land, but the very narrative written into its chemistry. The echoes of their ambition still ripple through our modern world. The very principles of hydrology we consider advanced today, from massive dam construction to integrated watershed management, may have their deepest roots in the forgotten practices of this lost civilization. Modern engineers often express a profound respect for ancient systems like the Sri Lankan Cascade tanks, networks of reservoirs that are still functioning after more than 2,000 years. This is not just a historical curiosity, it is a testament to a design philosophy so robust it has weathered millennia. The durability of these structures forces us to reconsider what true sustainability means and to look to the past for solutions to our current water crises. In arid regions of India, for instance, communities are actively reviving ancient water harvesting techniques, rebuilding stepwells and underground channels to combat severe drought with methods that these early engineers perfected. This is their direct legacy, a practical wisdom being unearthed not by archaeologists but by farmers desperate for water. Climate scientists have also turned their attention to these ancient sites, but for a different reason. They study the long-term geological and climatic data from these engineered landscapes to understand the lasting impacts of large-scale human intervention. The civilization did not just change the land for their own time, they created a permanent alteration to the local climate system, a change that is still measurable today. This research provides a crucial long-term dataset, showing us what happens when human control is applied to natural systems over centuries. It reveals a startling parallel to a modern phenomenon known as the urban heat island effect, where cities, with their concrete and asphalt, create localized warming that skews climate records. In a similar way, this ancient society created a fabricated climate baseline, a false signal of natural wetness etched into the geology. Their actions force us to confront a difficult question about our own data. How much of what we consider a pristine natural record has already been subtly shaped by ancient hands? This historical perspective offers both a warning and a source of innovation. Their grand endeavor shows us the potential power of treating climate as a variable to be managed, a concept that resonates deeply in our era of geoengineering debates. Yet their ultimate failure stands as a stark cautionary tale about the fragility of such controlled systems. The civilization's greatest lesson may be that while we can manipulate our environment with breathtaking skill, we must do so with a deep humility for the complex, interconnected systems we are altering. Their legacy is not just in the ruins they left behind, but in the critical choice they represent, a choice between dominating the planet and learning to work within its rhythms. These biological contradictions are the living ghosts of an engineered world. Entire ecosystems stand as silent testimony to a climate that never truly existed. You can walk through a grove of ancient trees thriving in the heart of a desert valley, a place where every natural law says they should wither and die. These are not miracles of adaptation, they are artifacts of human design. Ecologists studying these pockets of life find endemic species of plants and insects that demand far more water than the local environment can naturally provide. Their very survival is a paradox, a question written in leaves and roots that points to a hidden history of artificial support. The genetic code of these species holds the key. Scientists have identified severe bottlenecks in the DNA of certain trees, a telltale sign that they did not evolve here over millennia, but were introduced in a single event. Their genetic diversity is too low, marking them as a cultivated population, brought in by human hands and carefully maintained. Biogeographers who map the relationship between life and landscape note a stunning pattern. The distribution of specific flora and fauna does not follow the expected climate zones, but instead forms a perfect overlay on the map of ancient engineering sites. The plants and animals trace the outlines of the forgotten hydrological network, as if they were living markers placed along the veins of a lost civilization. This was a deliberate biological strategy. By importing and cultivating water-intensive species, the engineers were reinforcing their climatic narrative in the most persuasive way possible, with living, breathing evidence. A forest does more than just look lush, it actively modifies its own environment. Through transpiration, where trees release water vapor from their leaves, a cultivated grove can actually increase local humidity and seed the clouds for rainfall. They were building a self-sustaining illusion, using life itself to lock in their fabricated climate. The pollen record confirms this manipulation. Deep within sediment cores, layers of soil dating to the peak of this civilization's activity suddenly burst with foreign pollen. The dust of non-native trees and crops appears abruptly, with no gradual transition, signaling a massive, deliberate landscaping project. This is not the slow migration of species, it is the signature of a planned ecological intervention. Consider the sacred groves of India. These protected patches of forest, often surrounding temples, are revered as spiritual sanctuaries, but their true significance may be far older and more profound. Many of these groves are biodiversity hotspots, preserving unique collections of plants that are extinct in the surrounding regions. They may be the last surviving fragments of a much larger, human-managed landscape, a curated wilderness designed to project an image of eternal, natural abundance. Why go to such extraordinary lengths to manipulate biology? Because living evidence is the most convincing proof of all. A written record can be dismissed as myth, and a stone structure can be explained away, but a thriving forest in a barren land is undeniable. It tells every traveler, every future generation, that this place is and always has been fertile. It makes the lie tangible. This biological forgery was the final, masterful stroke in their grand deception, using the very force of life to cement a false reality into the world. This deep-seated need to command the natural world is perhaps the most powerful engine behind their grand design. Beyond the practical demands for water and food lay a profound psychological drive, a compulsion to prove absolute mastery over the chaotic forces of the planet. For any emerging civilization, the ability to control the environment is the ultimate source of security, prestige, and a legacy that echoes through the ages. Historians of science point out that this impulse is a common thread, one that weaves through the pyramids of Egypt and the ziggurats of Mesopotamia, a desire to leave an indelible mark that shouts our dominance to the heavens. This drive, however, carries a dangerous double edge, often leading to breathtaking achievements and then to a hubristic overreach that precipitates a fall. For this lost civilization, the engineering of climate evidence was likely tied to the very core of their religious and political identity. Their rulers probably positioned themselves as divine intermediaries, the sole figures who could command the rains and ensure the fertility of the land. By fabricating a geological record of perpetual abundance, they were not just storing water, they were manufacturing proof of their own godlike status. The monumental dams they built were far more than hydrological tools. They were towering symbols of this power, stone proclamations of their right to rule both the people and the planet. We see a clear parallel in ancient Egypt, where the pharaohs claimed direct control over the Nile's annual flood. Their entire reign was legitimized by their perceived ability to intercede with the gods for this life-giving event. In the same way, the builders of our lost civilization may have used their engineered landscapes as the ultimate propaganda, a physical, undeniable testament to their authority. This raises a reflective question for us today. How does this ancient psychological drive to dominate nature mirror our own modern efforts to combat climate change? We too are developing grand technologies, from solar geoengineering to carbon capture, in a bid to control a global system. The parallels are both striking and deeply instructive. Our ambition is fueled by the same desires for security and legacy, a need to secure a stable future for generations to come. Yet, we must ask ourselves, are we also risking a similar hubris? The story of this lost civilization serves as a sobering reminder that the power to reshape the world carries with it a profound responsibility, and that the line between salvation and overreach can be dangerously thin. The same fingerprints appear on different continents, scattered across the globe from the high Andes to the jungles of Cambodia and the plains of ancient China, lie the ruins of similar hydrological marvels. These are not just coincidental innovations, but structures that echo each other in their staggering scale and their puzzling placement. Comparative archaeologists who map these sites are struck by a profound pattern. Societies with no known trade routes, no shared languages, and no way to communicate all arrived at a nearly identical conclusion: to build massive, complex systems for controlling water on a scale that defies local need. The Incas built their intricate terrace and canal networks to cradle entire mountainsides. The Khmer Empire engineered the vast barrays or reservoirs of Anchor, which functioned as both spiritual symbols and hydrological powerhouses. In ancient China, the Duzhongyan irrigation system was a masterpiece of minimal disruption, taming a violent river without a dam. While each culture adapted to its unique environment, the underlying ambition feels eerily consistent. It was not merely about survival, but about imposing a new, stable order upon a volatile world. This points to a startling possibility that these were not entirely independent inventions, but perhaps local applications of a shared, ancient understanding of climate control. Could a forgotten global event have been the catalyst? Experts suggest a worldwide climatic shock, like a volcanic winter that blotted out the sun for years or a prolonged solar minimum that triggered centuries of cooling and drought, could have forced disparate civilizations to reach for the same desperate solution. Faced with a collapsing climate, the only answer was to build a new one. The proof may be locked in the mud. By comparing sediment cores extracted from these engineered sites worldwide, scientists could search for a synchronized pulse. A layer of volcanic ash found in cores from Peru, Mesopotamia, and the Indus Valley, all dating to the same decade, would provide a clear global trigger. Even more telling would be evidence of simultaneous construction booms, followed by eerily coordinated periods of abandonment. Around 2200 BCE, a wave of collapse swept through the Old World. The Akkadian Empire in Mesopotamia crumbled, the Old Kingdom of Egypt fell, and great cities in the Indus Valley were deserted. Historians have long debated a single cause. What if the thread connecting them was the failure of their climate life support systems? A prolonged drought that even their most brilliant engineering could not overcome would have shattered the illusion of stability, causing a domino effect of famine and social unrest. This global pattern reveals something fundamental about human ingenuity under existential pressure. When faced with the same terrifying uncertainty, our ancestors, separated by oceans, chose the same path. They looked at a changing sky and decided to rewrite the story of the earth beneath their feet. This shared response speaks to a universal drive to secure our future, a drive that now compels us to look beyond the ruins and ask what we are building today. A sudden catastrophe would shatter any society's illusion of safety, forcing a desperate choice between adaptation and oblivion. For this lost civilization, a singular disaster, perhaps a multi-generational mega drought or a coast-shattering tsunami, likely provided the ultimate motivation for their continental engineering. Geologists have uncovered fault lines running directly beneath the foundations of some of the most massive dams, with evidence of seismic repairs built into their original design. This suggests they were not just storing water, but actively fortifying their world against the very ground shaking beneath their feet. Disaster anthropologists point to a universal human response where cultures rebuild not just their cities, but their very myths to tame the memory of a cataclysm. They create stories of gods appeased and heroes who saved the day, transforming a chaotic event into a narrative of control. Engineering the climate evidence could have been the physical manifestation of this impulse, a way to literally bury the truth under layers of fabricated geology. Why would a society invest such immense resources in denying a disaster ever occurred? The answer lies in the foundation of power itself. To admit vulnerability is to risk chaos, but to present an unbroken history of abundance and stability is to claim divine or technological invincibility. Take the cataclysmic eruption of Thera around the 16th century BCE. This event likely caused global cooling, failed harvests, and societal collapse across the Mediterranean. For a civilization like the Minoans, engineering projects to counteract the volcanic winter, and then systematically covering the evidence of that crisis with new sediment, would have been a strategic move to project an image of uninterrupted prosperity and control. Along certain coastlines, scientists find tsunami deposits buried beneath meticulously placed layers of dam-controlled silt. It appears the civilization's engineers did not just build seawalls, they actively worked to mask the signs of the disaster itself, creating a geological record that showed a placid, undisturbed coastline where a wall of water had once ravaged the land. This was more than engineering, it was historical revisionism carved into the earth. By controlling the narrative of past catastrophes, the ruling class could present themselves as the guarantors of a perfectly stable world, a fiction so convincing it became embedded in the very soil. This drive to erase vulnerability reveals the profound psychological weight these projects carried, a burden that leads us to question the ultimate cost of maintaining such a perfect and perfectly false reality. The stars themselves were part of their machinery. Scattered near the colossal dams and engineered valleys, we find the remains of observatories, simple stone circles, and aligned monoliths that seem to track the heavens. These were not temples for stargazing alone, they were the control panels for the entire hydrological system. Archaeoastronomers have mapped these sites and discovered a stunning correlation. The spillways of major dams are often perfectly oriented toward key celestial events, like the summer solstice sunrise or the heliacal rising of the star Sirius. In ancient Egypt, the appearance of Sirius heralded the Nile's annual flood, a natural event that entire societies were built around. This civilization appears to have replicated that natural signal, using celestial timing to trigger the release of water from their own artificial reservoirs. The coordination required for this is breathtaking. To simulate a believable, seasonal water cycle across a continent, the releases had to be perfectly timed. A sudden, unseasonal flood would leave a chaotic geological signature, but a release timed to the stars would create a predictable, rhythmic pattern of sediment deposition. This would build up layers of silt and clay that looked exactly like the result of thousands of years of reliable, annual flooding, forging the ultimate proof of a stable climate. The precision involved is staggering. Expert analysis confirms that timing the water flow with celestial cycles, such as specific lunar phases, could create micro-layers in the sediment that appear to be annual varves, those fine bands laid down each year in a lake bed. They were not just building a landscape, they were writing a calendar into the earth itself, a false timeline of perfect seasonal regularity. A fascinating case study comes from the Sunghir site in Russia. Here, intricately carved bone artifacts, marked with precise patterns of dots and lines, have been interpreted by some researchers as ancient lunar calendars. While their purpose is debated, they showcase the level of astronomical calculation possible in prehistoric times. If such knowledge could be applied to tracking animal migrations, why not to orchestrating the flow of water across an engineered continent? This integration of celestial knowledge with terrestrial engineering reveals a truly holistic worldview. They saw the sky and the earth as a single, interconnected system. By synchronizing their massive water releases with the cosmic clock, they could make their fabricated climate hum with the convincing rhythm of nature itself. This celestial choreography was the final masterstroke, a way to make their grand illusion not just look real, but feel real, beating in time with the universe. Such monumental construction demanded an economy of staggering scale. To carve valleys and raise dams across continents, this civilization needed more than just brilliant engineers. It needed a system capable of feeding, housing, and mobilizing a colossal workforce for generations. This was not a task for a subsistence society, but for one that had mastered the art of creating a massive, reliable surplus. The entire endeavor rested on a foundation of agricultural abundance, where enough food was consistently produced to free thousands of hands from farming and dedicate them to the grand work of terraforming. Economists who study ancient systems point to a clear pattern. Projects of this magnitude only emerge when wealth is heavily concentrated and directed by a powerful central authority. This suggests a ruling class with the vision and the power to command the labor of an entire civilization. Historians of ancient labor describe how such efforts were often organized through systems like corvée labor, where citizens contributed a set number of days each year to public works as a form of taxation. In some cases, slavery provided the brute force, but for a project requiring sophisticated skill and long-term commitment, a system of incentives was likely crucial. The promise of food security in an engineered, fertile landscape would have been a powerful motivator for entire communities to participate. This creates a fascinating feedback loop. The very act of building the climate control systems would have boosted agricultural output by guaranteeing water and stabilizing temperatures, which in turn generated more surplus wealth to fund further construction. The engineered climate was not just an environmental project, it was the engine of the economy itself. We see evidence of this highly organized economy at the engineering sites themselves. Archaeologists have uncovered standardized weights and measures, and in some places, early forms of currency or trade tokens. These tools were essential for a centralized administration to allocate resources efficiently, paying workers, procuring materials, and managing supply chains that stretched for thousands of miles. The Roman Empire offers a clear parallel, where wealth extracted from conquest and a sophisticated tax system funded immense infrastructures like aqueducts and roads, projects that then reinforced Roman economic and political control. This raises a reflective question for us. What kind of economic structures are necessary to sustain projects that span centuries? They demand more than just resources. They require a profound societal stability and a unifying vision that can be passed down through generations, a testament to an economic and political system powerful enough to bend the very earth to its will. The words they left behind may be the final key to unlocking their secret world. Across scattered tablets and weathered stone stelae, we find inscriptions that speak of commanding the rivers and carving the very bones of the earth. For generations, scholars dismissed these as the grandiose boasts of arrogant kings, mere poetry celebrating their power. But what if we have been reading them wrong all along? What if these are not metaphors but literal technical manuals? A Sumerian cuneiform tablet, for instance, might describe a ruler who made the water follow his word, a phrase once seen as divine hyperbole. Yet when we locate the geographical region he ruled, we find the precise, unnatural channels of a rerouted river system, a perfect physical match for the textual claim. This forces a dramatic reinterpretation of history. The myths were not just stories, they were encrypted reports from the front lines of a terraforming war. Linguists studying long-dead languages have isolated specific terms that defy straightforward translation. In ancient Akkadian, the word epshu appears in contexts far beyond simple work or deed. It is used to describe projects that reshape the horizon, an activity that aligns perfectly with the large-scale land carving we see in the dry valleys. Similarly, certain Egyptian hieroglyphs depict roles like master of the canals and overseer of the high waters, titles that suggest a specialized, powerful class of hydrological engineers, not just simple farmers managing irrigation ditches. These were the professionals who operated the continent-spanning machinery of climate control, epigraphers, the experts who decipher ancient inscriptions, constantly warn of the blurred line between myth and history in these texts. A saga about a god defeating a water serpent could easily be a cultural memory of a monumental engineering project to tame a flooding river, its success later attributed to divine intervention. The recurring symbols found at these sites tell their own silent story. The zigzag line, a near-universal sign for water, appears in fascinating contexts. In natural settings, it flows freely, but at the sites of ancient dams, it is often depicted contained within geometric shapes or interrupted by straight lines, as if showing water being managed, controlled, and directed by human design. This is the difference between describing a wild river and illustrating a plumbing schematic. A compelling case study lies in the Indus Valley civilization. Their script remains one of history's great unsolved puzzles, but certain repeated signs are tantalizing. One symbol resembles a comb or a gate, which some researchers speculate could represent a sluice gate or a weir. Another looks like a network of interconnected rectangles, a possible diagram for a linked reservoir system. If we could ever read their words, we might find they were not talking about kings and gods, but about water pressure and sediment flow. Why would a civilization so carefully record these environmental manipulations? The answer is one of profound necessity. This was not knowledge they could afford to lose. The survival of their entire engineered world depended on the meticulous transmission of technique from one generation to the next. Inscribing these methods in stone and weaving them into the foundational myths of their culture was the only way to ensure that the dam maintenance schedules were followed, that the celestial timing of water releases was understood, and that the great deception of their stable climate could be maintained indefinitely. They were building a permanence for their knowledge, ensuring that even if their cities fell, the instructions for rebuilding their world would endure. This very act of recording, meant to cement their control, ultimately becomes the evidence that betrays their grand illusion, leaving a coded confession in plain sight for millennia. The echoes of their ambition resonate directly in our most urgent modern debates. These ancient engineers were the first geoengineers, grappling with the same core dilemma we face today, the desire to control a climate system that feels increasingly hostile. Their story provides a sobering, real-world case study for proposals like solar radiation management, the idea of spraying reflective particles into the upper atmosphere to cool the planet. Climate policy experts point out that the risks these ancients faced are hauntingly familiar. Their systems, while brilliant, created a profound dependency. When a drought exceeded their engineered capacity, the collapse was not a slow decline but a catastrophic failure, because the natural resilience of the landscape had been replaced by a fragile, human-made substitute. This is the ultimate unintended consequence, solving one problem while creating a far more dangerous vulnerability. Environmentalists caution that our own large-scale interventions could follow the same path, offering a temporary fix while locking us into a cycle of managing the side effects, from disrupted rainfall patterns to unknown impacts on global agriculture. The question is not merely technical but deeply ethical. Was their approach sustainable? The ruins suggest a grim answer. It was sustainable only as long as their knowledge and power remained absolute, a condition that history shows is always temporary. This historical collapse directly informs the precautionary principle in modern science, the idea that we should avoid actions with potentially catastrophic, irreversible outcomes, especially when the science is not fully settled. Yet within their failure, there are also seeds of hope. We are now rediscovering their techniques and adapting them for our own challenges. The ancient terra preta soils of the Amazon, dark, fertile earth engineered by indigenous peoples centuries ago, are a powerful example. These soils are not just rich for farming, they are remarkable carbon sinks, locking away atmospheric carbon for millennia. Modern agricultural researchers are actively studying this biochar technology as a way to combat climate change while improving soil health. Similarly, the revival of ancient water harvesting methods like the stepwells of India offers sustainable solutions for water conservation in drought-stricken regions. This forces a profound and reflective question upon us all. Should we view climate engineering as a desperate last resort, or can it be a viable tool in a broader portfolio of solutions? History suggests a clear verdict: caution. The ancient civilization's grandest efforts were not about working with nature's rhythms, but about overriding them. Their legacy is a warning that the power to control the climate is also the power to accidentally break it, a responsibility that demands more humility than hubris. The trail of their tools leads across continents. Archaeologists have long been puzzled by the discovery of specialized artifacts, like precisely carved ceramic pipes and heavy stone sluice gate liners, found hundreds of miles from the quarries where their raw materials originated. These are not decorative trinkets or common goods, but the specific, heavy components of water management systems, turning up in regions that lack the native stone or clay suitable for their construction. It is the equivalent of finding a car engine in a village with no roads, a clear sign that the technology was imported. Trade historians point to the extensive movement of materials like bitumen, a natural tar used for waterproofing canals and reservoirs. This sticky, black substance was traded along established routes, creating a tangible link between distant dam sites and engineered valleys. The exchange was not just about goods, it was about ideas. When one culture learns a better way to build an arch from another, the innovation spreads, accelerating the pace of engineering. This rapid, shared advancement could explain how the techniques for climate evidence engineering appeared so swiftly and so widely. To implement such a vast program, the civilization likely established remote outposts, colonies dedicated solely to the task of terraforming. These outposts would need a constant supply chain, fed by trade networks that brought in everything from bitumen and specialized tools to the food needed to sustain the workers. We see potential evidence of this in Central America, where Olmec-style artifacts, including distinctively carved jade and ceramic figures, have been found in dry valleys far from the Olmec heartland. This could signal the presence of Olmec engineers or traders, sharing the knowledge required to reshape those arid landscapes. A powerful case study is the architectural arch, a revolutionary design for supporting immense weight. This feature first appears in Mesopotamian dam construction, allowing for stronger, taller structures. Then we find the same principle, with nearly identical mathematical proportions, in dam ruins in South America and Asia. This is not a coincidence, it is a blueprint that traveled. What do these far-flung artifact trails ultimately reveal? They paint a picture of a civilization with a truly global reach, not in the sense of political empire, but as a coordinated, informed network. It was a web of knowledge and supply, all directed toward a single, staggering goal: ensuring that the same environmental story was being written into the geology of the entire world. Their worldview was a radical break from the past. For this civilization, nature was not a sacred mother to be appeased, but a chaotic wilderness to be tamed and ordered, a raw material waiting for the imprint of human will. This philosophy of supremacy likely grew from an initial, intoxicating success. The first farmers who diverted a stream to water their fields experienced a new kind of power, the power to command life itself. This small-scale control created an illusion, a belief that with enough knowledge and effort, the entire environment could be bent to human purpose. Philosophers of ancient thought point to a recurring theme across early empires, the concept of bringing order from chaos. In their myths and state ideologies, the natural world was often depicted as a formless, dangerous void that required a heroic, often divinely sanctioned, effort to structure and civilize. This was not just a spiritual idea, it was a blueprint for action, a justification for reshaping rivers and carving mountains. This perspective created a deep cultural schism. Ethicists highlight the stark contrast with many indigenous worldviews, which often emphasize living in dynamic balance with nature, seeing humanity as one part of a complex, interconnected web. The civilization we are investigating positioned itself as the master of that web, the weaver who could redesign the entire tapestry. Their religion and cosmology were almost certainly engineered to support this ambition. If their rulers were seen as gods on earth, or as the chosen representatives of the gods, then their monumental engineering projects were not mere public works, they were a divine duty. The act of controlling the climate and fabricating its evidence could have been framed as the ultimate fulfillment of a celestial mandate, a test of human potential passed down from the heavens. We can see this reflected in ancient texts that are often read as creation myths, but might be something else entirely. The Babylonian epic, the Enuma Elish, describes the god Marduk battling the primordial sea monster Tiamat, slicing her body in two to create the orderly heavens and the earth. This could be a powerful metaphor for their own colossal engineering, a mythological retelling of their struggle to partition the chaotic, watery abyss into manageable canals and reservoirs, creating a world of human-defined order from natural chaos. Their entire belief system would have reinforced this mission. Why would a society choose such a difficult path to fight nature rather than adapt to its rhythms? The answer lies in a unique and desperate historical context. Perhaps they emerged from a catastrophic environmental collapse, a trauma so profound that their deepest cultural drive became the absolute avoidance of ever being vulnerable again. Their grand projects were not just about controlling water, they were about conquering fate itself, an attempt to build a world where chance and chaos had no place, and where humanity sat, unchallenged, at the very center of a created universe. This philosophical foundation made their engineering possible, but it also sowed the seeds for a perilous future, one where any failure of their systems would be seen not as a practical problem, but as a cosmological one, shaking the very core of their identity and their right to rule. This journey through fabricated valleys and silent dams forces a profound conclusion. We are not merely looking at the ruins of a forgotten people, but at the ghost of a philosophy, a radical belief that humanity could become the author of the natural world. The evidence we have uncovered, from the chemical lies in the soil to the celestial timing of water releases, paints a portrait of staggering ingenuity shadowed by immense risk. This civilization story is not a simple tale of rise and fall. It is a complex mirror reflecting our own ambitions and anxieties back at us. Their drive to eliminate uncertainty, to forge a stable world from a volatile one, is an impulse we understand all too well in our own age of climate instability. They achieved wonders, but their legacy is a landscape of both grandeur and collapse, a cautionary tale written in stone and sediment. The philosopher George Santayana's warning echoes across the millennia that those who cannot remember the past are condemned to repeat it. Their forgotten history offers us a priceless gift, a long-term case study in the consequences of geoengineering. We can draw inspiration from their brilliance, from water systems that still function after thousands of years, and apply that ancient wisdom to modern sustainability. We can learn from their hubris, from the fragility of systems that replaced natural resilience with a brittle, human-made substitute. Their world, built on a foundation of controlled climate, ultimately could not withstand the test of time. As we now debate our own planetary-scale interventions, their ruins stand as a silent, sobering monument. They whisper that the power to control our environment is also the power to break it, a responsibility that demands more humility than hubris. This exploration does not end here. It simply opens a door. What other secrets lie buried in plain sight, hidden within the very geology we walk upon every day? If this glimpse into a lost chapter of human ambition has intrigued you, we would love to hear your thoughts in the comments below. Subscribe for more journeys into the deepest mysteries of our past, where history is never quite what it seems.